All right, everybody. Thank you for joining us today, for joining us in our webcast today. This is part of our webcast series, the Deep Dive Enterprise Manager webcast series. Today's topic is database performance tuning and diagnostics, best practices for both your on-prem as well as your cloud infrastructure. We'll be sharing with you today, I have Alfredo Krieg. He's a Principal Security and Management Specialist. He's great with Enterprise Manager. And my name is Tim Mooney. I am Product Marketing Director. So before we get going, I just want to point out that as a part of this series, if you like what you see today, we have others on the schedule as well as previous webcasts on demand. So follow that link on the bottom of the page. All right, the agenda is definitely a deep dive. We'll go into diagnostics and tuning of databases. Alfredo will take you through an overview as well as some actual demonstrations using Enterprise Manager tools. Once he's done, I'll give you a quick business profile. We'll show some of the monetary benefits, the business benefits of using Enterprise Manager. And then most importantly, we have Q&A. We will have a little dedicated time at the end, but use that Q&A tab throughout our session. We're running this session for you guys, and I think it's proven to be very valuable to leverage our experts, ask your questions in that Q&A channel. If we can't get to them during the session, we'll be able to follow up with you. And then we'll do a quick wrap with some additional resources and we'll be done. So with that, let me turn it over to you, Alfredo.
Thank you, Tim. Good morning, good afternoon, good evening, everyone. Let's get started with this presentation about database performance tuning and diagnostics best practices for on-premises and cloud infrastructure. We know that Oracle Enterprise Manager is Oracle's integrated enterprise information technology management product line, which provides the industry's only complete, integrated, and business-driven enterprise cloud management solution. Oracle Enterprise Manager provides a single pane of glass for hardware and software management across cloud and on-premises targets. It also provides a centralized control of integrated diagnostics, tuning, and lifecycle activities. The fleet-wide automation across Oracle Cloud and on-premises assets process helps administrators to ease all that lifecycle management activities they're involved with. Also, Oracle Enterprise Manager is integrated with name credentials and auditing. Oracle Enterprise Manager's functionality can be further extended by adding one or more optional management packs. I'm showing here in this slide all the available packs for the Oracle database. And all these packs, combined with Oracle Enterprise Manager's console and framework, help and allow administrators to better integrate solutions for diagnostics and tuning, real application testing, also database lifecycle management activities, the database cloud management pack, and of course, data masking and subsetting. All these diagnostics packs can be accessed via either database server APIs, using, of course, the Oracle Enterprise Manager Cloud Control 13c, but also some of them can be accessed by using Enterprise Manager Express. This is available on database 12c and higher versions. Also, some of the features can be accessed using SQL Developer. Let's get started with the Database Diagnostics pack. The Database Diagnostics pack provides real-time and automatic performance diagnostics and monitoring functionality for your Oracle database. All this core functionality of the Database Diagnostics pack is built in the Oracle database kernel, and of course is exposed through Oracle Enterprise Manager interface. is also seamlessly integrated with the tuning pack and real application testing functionality. And we're going to be covering that in future slides. The database diagnostics pack has a portfolio of tools inside, which we're going to be covering here. The first one is, of course, the concept of using DB time. DB time is nothing more than the total workload that the database is performing during a period of time, right? We also have the automatic workload repository. We call it AWR. And inside this automatic workload repository is where this kernel code is storing all this performance data that is gathering. Then we make use of this AWR repository and all the views that AWR is exposing to understand how the performance was in the past, and we can start comparing actual performance with performance that happened probably last week, yesterday, or the day before, and then that helps you understand what changed in the database. We're going to be covering the AWR Warehouse. We have the Automatic Database Diagnostic Monitor. We call it Addm. Another cool feature of the Diagnostics pack is Active Session History, ASH. We have all the Exadata management that is covered inside the Diagnostics pack. That means when you discover and you manage and monitor your Exadata, you require the Diagnostics pack in order to do that. And last but not least, we have the System Monitoring and Notification System. As I mentioned, the Automatic Workload Repository is a repository of historical performance data. All this performance data is being gathered by the database itself and is stored inside a table space in your database. All this data includes cumulative statistics for the system, for the sessions, and also individual SQL statements, segments, and services. It also includes high-load SQL statements. It includes the concept of the database time at the database level and as well as the session level. So you can start comparing and gathering information about the amount of workload that the database is processing, either at the database level as a whole or at the session level. We also have object statistics for segments, such as tables, indexes, and other database objects. These statistics are the foundation of performance tuning. Without this data, it will be really difficult for us to go back in time and understand how was the performance before the issue that we're facing right now in the database, right? So how this works? As you can see in this slide, we have in the right side, we have the database instance. The database instance is comprised of memory area pools and processes, right? Inside the kernel code, we have instrumentation of the database. That instrumentation, what it's doing is gathering all these statistics and is storing those statistics in the SGA, okay? Because it's a memory pool in your server. Then we have a background process named MMON that is going to gather these statistics every hour and is going to create an AWR snapshot. An AWR snapshot is nothing more than a picture of your database at a given time, right? We're going to be storing that inside the AWR repository. The database is going to store these snapshots, these pictures of the database inside a table space named sysocs, okay? And of course, we have rotation and we have maintenance of this information. And these older snapshots are purged as this configurable snapshot retention policy. That means that you can go back and instruct the database and say how much data you want to store in that particular AWR repository. By default, we have 8 days. Our recommendation is to modify that accordingly to your business needs, right? Keep in mind that the more data you store, the bigger the SysOx table space is gonna get. So now that takes me to the concept of AWR Warehouse. And AWR Warehouse is a central warehouse that you can configure for long-term AWR data retention. In my previous slide, I mentioned that the more data you store, the bigger that SysOx table space is gonna get, right? So what happens when you start gathering snapshots, let's say every 15 minutes, because that's what your business is in need of, and your retention policy is, let's say, 180 days that you're required to store that performance data. You are required to go back in time and compare the performance back to 180 days, right? That SysOx table space is gonna grow big. That brings several challenges, right? The first one that comes to my mind is backups. You're gonna be backing up this data. Your backups are gonna be getting bigger as well. When you clone databases, let's say you have a requirement to clone this production database to test, dev, or QA environments, then you're cloning this data along with. So you are using more and more data for your clone databases, right? So in order to overcome this, inside Oracle Enterprise Manager, we have this AWR Warehouse functionality. That means that you create an additional Oracle database that is going to serve as an AWR Warehouse repository. And then you configure Enterprise Manager. As you can see, you instruct Enterprise Manager which ones are going to be your source databases. Okay? These source databases are going to be configured in Enterprise Manager, and Enterprise Manager has ETL jobs. These ETL jobs, their functionality is to go to these source databases, extract this AWR data, and import the data into your AWR warehouse. This is using Oracle Data Pump in the background, right? And last but not least, you can configure the retention period for this AWR warehouse. By default, is forever. That means that you can store this data forever. You can go back in time, let's say, how was the performance of this production database 2 years ago, right? It's a useful feature for Oracle database administrators. So this is a screenshot of an AWR Warehouse Dashboard. As you can see, we have an AWR warehouse that is 63 terabytes in size. We have 713 databases, and also we have an issue. We have one database that is not uploading recent data, right? On the lower part of the snapshot, you can see that we have our target databases, the target types, the database names, if the ETL jobs are enabled or not, if there are any incidents, any errors in extracting that AWR data, and how many days we have worth of AWR data for each of the databases, right? You can also use this performance page to understand how much data you're loading, how much data you're generating. And from here, you can create AWR reports. You can call Ash Analytics to find out how the performance is. You can also execute compare period ADDM reports and also compare period AWR reports. As you can see, this is integrated seamlessly into the Oracle Enterprise Manager UI and is zero runtime overhead on the source production database when we extract the data. We have also active session history, ASH. The way ASH works is we're going to be sampling active sessions, and I quote again, active sessions. This is an important concept. Every 1 second into memory. And you can query this data by using the system view $$ active session history, right? Active session history helps to answer a couple of questions like, has this SQL gotten slower over time, right? Active session history has direct access to kernel structures. That means that the kernel code of the database is the one that is responsible of this sampling. And 1 of 10 samples are flushed to AWR at every snapshot that we take. That means that you have to keep in mind that this is not 100% accurate data. This is a sampling, but it's good enough to understand how the active sessions are performing in our database system. Some of the data that is captured includes the SID, of course, the SQL ID that is executing, right? The program, the module, and the action. We also have the wait event number, and also the object, the file, the block, and the actual wait time, if when we're capturing that session is waiting, right? All this information enables the administrator to have a target performance analysis for transient problems in the database. That means that you can define a range where you want to get that active session history report. You can also filter by wait events. So you can say, I want to filter during this period of time of the sessions waiting on this particular wait class, right? So it's really important tool when we're troubleshooting performance issues. Moving forward, we have the automatic performance diagnostics. And this is the way we call it is the continuous evolution in database performance management. So ADDM helps us to diagnose persistent performance issues. It also makes use of AWR snapshots. So at the end, we're going back to the basics where without AWR data, we will not be able to understand the database performance. This ADDM can run at a regular interval, and you can configure ADDM to run either automatic or manual, right? We also have the option to run a compare period ADDM that is going to provide us in-depth performance comparison across 2 periods. That means that we instruct ADDM to get one snapshot and compare that against a different snapshot. Again, it relies on AWR data, and this is a manual task that you have to manually start, okay? We have also real-time ADDM, and that helps us to understand why a database is extremely slow or when the database is hung. That means that you're not able to connect to the database. It uses a normal, but also has the ability to connect to the database in diagnostic mode. That means that we have a backdoor in the database where we allow ADDM to connect and provide you information on what's happening in the database when you're not able to connect normally. This one you have to start it manually, and I'll show you some of the screenshots that we have for real-time ADDM just in a minute. Last but not least, we have the enhanced real-time ADDM, which proactively is going to detect and diagnose transient high-impact problems. This one is built inside database and is running automatically every 3 seconds. For the automatic database diagnostic monitor, the standard ADDM, you can see that we have a chart with a time frame of snapshots. These are the available snapshots that we have in our database, in our AWR repository. And then you will have to select which one is going to be the beginning and the end snapshot. You instruct Addm and it's going to produce a report. You can see in the lower part of the screenshot that there is an impact of 95%, and the finding is top SQL statements. That means that Addm is finding that some SQL statements have an impact in the performance database of around 95%. Okay? You can click on that finding and it's going to give you a detailed information of which SQL statements are the ones that are consuming or have a higher impact in the database performance. For real-time Addm, we have the top activity graph. You can see that this is for the last hour, right? On the middle screen, you can see 3 buttons. The first one is Start. That means that you have to manually go and click Start in order to initiate the process of connecting to the database. You can stop that process or you can restart that connection. Then when Addm is done gathering all the needed information, it's going to produce that report that I'm showing you here. So I click on Activity. You can see that there is a SQL ID that is highlighted in red, and also the activity of that particular SQL ID is giving you the user session information and also the activity in average active sessions, right? We have also a graph that is showing you which weight classes are the ones that are consuming more resources in your database. In this example, we have that most of our sessions are consuming CPU. The database tuning pack provides a unique, automatic, and deterministic SQL tuning functionality. Okay? All this functionality is also built inside the Oracle database kernel, and the same way as the database Diagnostics pack is exposed through the Oracle Enterprise Manager interface. It's also integrated with the Diagnostics pack, the real application testing, and automatic tuning optimizer functionality. Some of the tools inside the database tuning pack are SQL tuning sets. We have the SQL Tuning Advisor. We have SQL Profiles, the automatic SQL tuning, SQL Access Advisor. We have RealTime SQL, PL SQL, and database operations monitoring. And we also have the ability to reorganize objects. So what is a SQL tuning set? A SQL tuning set is a database object. This SQL tuning set includes a set of SQL statements. It can include one or multiple SQL statements. That means that we can call it a container of SQL statements. Okay? It also contains all the associated execution context. That means the user schema, the application module, the action, if it has any bind values, all the bind values are inside the SQL tuning set, and also the environment for the SQL compilation of the cursor. All the information of the cursor is inside the SQL tuning set. It also has all the associated basic execution statistics. That means elapsed time, CPU time, buffer gets, disk reads, the number of rows processed, how many cursor fetches that SQL statement had to execute, the number of executions, the number of complete executions, the optimizer cost, and the command type that was used. All the execution plans and the row source statistics are also included inside the SQL tuning set. We can also make use of Oracle Enterprise Manager to create SQL tuning sets. We can click the button Create. We specify a time frame where Oracle Enterprise Manager is going to start capturing SQLs, and it's going to be starting storing those SQL statements inside that particular tuning set, right? You can filter SQLs. It has different advanced filtering options for you. You can transfer these SQL tuning sets between databases. And the idea is, if you're troubleshooting an issue on a production database, you can go ahead and create a SQL tuning set that contains the SQL statements that you're interested in fix. Then you transfer that SQL tuning set to a test environment that is similar to that production database, and then you can start doing the troubleshooting or modifying those SQL statements in that test environment without affecting production. The way you transfer that, you can go and manually execute commands, but if you use Oracle Enterprise Manager, you can click on that copy to a database button. Basically, what you require is a directory object that was created in that database. So Oracle Enterprise Manager is going to run behind scenes all the exporting and importing for you. If you want to do it manually, you can also click on export to a file, and then you can import from a file inside the test database that we mentioned. Let's move now forward to the SQL Tuning Advisor. The SQL Tuning Advisor is going to give you suggestions on the problems that were identified during the diagnosis phase. That means that you have to instruct SQL Tuning Advisor to start diagnosing SQL statements. You can ask SQL Tuning Advisor to diagnose and analyze one SQL statement or multiple SQL statements by providing a SQL tuning set, right? It's gonna use in the background the same CBO, the cost-based optimizer, but has more time to budget to perform comprehensive analysis. What this means, when you are parsing a SQL statement, right? Basically what you're doing is you're passing the SQL text, and then you instruct the database to generate an executable code inside the RDBMS. The cost-based optimizer has microseconds to identify multiple execution plans and then choose the best execution plan for that particular SQL statement, right? So it has limited time during the parsing operation. When you instruct the SQL Tuning Advisor to analyze a SQL statement, then you can define that time frame that the SQL Tuning Advisor has for that particular operation. By default is 5 minutes. So just imagine in 5 minutes how many execution paths can the CBO find for that particular SQL statement. That means that it has more time to analyze more paths and give you a better execution plan for that particular SQL statements. Again, SQL Tuning Advisor is going to identify these alternate execution plans using the real-time and historical performance data that we already have inside AWR. And it's going to recommend SQL profiles, or it's going to recommend gathering missing Ulster statistics, or adding missing access structures like an index, or create a materialized view, modify SQL constructs, adapt alternative execution plans, or even create a parallel SQL profile if the CBO finds that running a parallel SQL is better than a standard SQL statement. And then at the end, it's up to the administrator to accept those recommendations inside the database. Let me give you an example. So this is a dashboard of a recommendation that came out of the SQL Tuning Advisor. You can see that we have the SQL ID highlighted. We have the SQL information. So it's giving us information about the SQL text, the PDB name, and the parsing schema. And then it has a table where it's providing you the recommendations after the analysis, right? So you can go ahead and click that compare explain plan, for example, for the first recommendation, which is a SQL profile. You can see that the benefit of implementing that SQL profile is around 58%. You can click on compare explain plans, and it was going to provide you information of what is the original execution plan compared with the new explain plan that's going to be created if you accept that SQL profile. The second recommendation is to create an index, right? It's giving you information about where it's going to create that index. In this case, is the customers table on the cost city and the cost ID columns, right? The benefit around 72%. You can also see the new explain plan, or you can compare those explain plans. If I click on compare explain plans for the SQL profile, I get a page like this one, the one that I'm showing you right now. This is the execution plan comparison. We have the compare explain plans. We have the original plan on the top, along with the plan hash value. And also we have the new explain plan with the new hash value, and you can see the difference in the cost. The original one is around 31,000. You can see the time is 376 compared with the cost of the new one, which is 4,727, and the time is around 57, right? Much better than the original one. So when you create a SQL profile, right, out of the recommendation of the SQL Tuning Advisor, what is a SQL profile in the database? A SQL profile is another database object. This SQL profile, as I mentioned, contains auxiliary information. This is collected by the SQL Tuning Advisor for that particular SQL statement. It contains customized optimizer settings. It also contains that compensation for missing or stale statistics, or compensation for errors in optimizer estimates. It doesn't require any changes to the original SQL text. Okay, so that means that you can implement that inside your database without asking your developers to modify the SQL statement. It is persistent. That means that it works across shutdowns or upgrades. You can transport that across databases. This is functionality coming from 10.2 version of the database. You can force match option for literals in a SQL text. And also this enables you to test a profile in a restricted environment before making it available to other sessions. This is really useful to test it out before other sessions can see this SQL profile, right? So the way it works is you have the SQL statement, you create the SQL profile, right? That is coming out of the optimizer. The SQL profile is injected inside the optimizer. You have environment data like optimizer statistics, bind variables, configuration, data sets. So both the SQL profile and all the environment settings are injected inside the optimizer. The optimizer creates the new plans using all the algorithms that it has inside. And then as a best practice, we recommend to use SQL Plan Baseline to create the baseline and lock that plan that is working optimally for that particular SQL statement. Okay. If you use Oracle Enterprise Manager, you can go to this specific dashboard that is named SQL Plan Control. You can see that we have 3 tabs. The first one is for SQL Profiles. We also have another one for SQL Patch and SQL Plan Baselines. You can manage the full life cycle of that SQL, all the SQL profiles in your database. You can see that we're showing you all the available SQL profiles in this particular database, along with the SQL text, any category, the status, when it was created and when it was modified. You can also use Oracle Enterprise Manager, this particular functionality, to transfer SQL profiles between databases. That goes back to the example that I was telling you. If you create SQL tuning sets and you transport the SQL tuning set to a test environment, then you can run SQL Tuning Advisor, create a SQL profile, and then transfer that SQL profile back to your production database. So you run all the heavy workload of running SQL Tuning Advisor and testing out everything in the test environment. Then you just transfer the result, which is a SQL profile, to your production database when you feel that it's going to generate an optimal plan for that particular SQL statement. We also have the automatic SQL Tuning Advisor. So we saw that using SQL Tuning Advisor, you can manually call the advisor and start analyzing a SQL statement. Well, using the automatic SQL Tuning Advisor, you can instruct that you can configure a SQL Tuning Advisor to run automatically in your database. So based on the AWR data that it has, what is going to happen is going to choose a candidate SQL, then it's going to run SQL Tuning Advisor. It's going to generate recommendations for you. It's going to test SQL profiles. And last but not least, if you enable that option, the automatic SQL Tuning Advisor can also implement SQL profiles. If not, it will generate a report, and it's up to you to go and manually review the report and manually enable those SQL profiles that were recommended. I'm showing you the automatic SQL tuning configuration. You can see that the task status is set to enable. That means that automatic SQL Tuning Advisor is going to run automatically. But you can also see that the automatic implementation of SQL profiles is currently disabled. That is by default. This report is showing you the summary in time period. You can see the number of executions, the number of candidate SQLs that were identified during the run, the number of distinct SQL examined, and also you see how many SQLs were found with findings. That means that there is a better execution plan, or there is a SQL profile that can be implemented, or sometimes an index can be a better option for that particular SQL. We also have the SQL Access Advisor. So when we try to create an index or a new structure in our database, we want to make sure that that is the right approach for that particular SQL. That means that this SQL Access Advisor is going to analyze the entire workload that we have, not just individual SQL statements. It will take into account the impact of new access structure on DML operations as well. It will consider the storage needed for creation and maintenance costs. It will also consider index solutions or materialized view solutions, and or combination of an index or a materialized view. It will optimize the materialized view for maximum query rewrite using either the standard query rewrite or fast refresh for that materialized view. Okay. The way it looks like is this is an example of a result of a SQL Access Advisor task. On the summary section, you have the overall performance impact for those recommendations. In red, you can see the original cost. In blue, you see the new cost, which is lower than the original one. On the bottom of the screen, we have the number of recommendations. We have 2 of them. The space requirement for the index creation. And on the right side, we have the number of SQL statements that were analyzed during that particular session. We also have real-time SQL monitoring. And real-time SQL monitoring is one of the best features available for this tuning pack. it will automatically monitor long SQL running statements. So after a specific period of time of the SQL running, real-time SQL monitoring is going to pick up that SQL statement, is going to show you that SQL statement inside the SQL monitoring screen. It's enabled out of the box. There's no performance impact on enabling this. It will monitor each SQL execution, and it will expose several monitoring statistics like the global execution level, plan operation level, and parallel execution level. You can see that we have the status, we have the duration, the SQL ID, the SQL plan hash value, the username, and the PDB that it's running on, if there is any degree of parallelism, the database time that it took for each of the executions, the IO requests, and the SQL text. All the bind values are shown. And also we have this graphical explain plan view that I'm going to be showing you in the next slide. And as I mentioned, we have IO statistics for each operation. This is an example of how a real-time SQL monitoring page looks like for a specific SQL ID. I'm highlighting information about the SQL ID. If the SQL is running on any parallel degree, we can see that we have 6 of them. Any time and wait statistics, the duration, and also details of the execution plan, right? We have the select statement, then we have the parallel coordinator and the slave coordinator of the parallel query. We have on the row number 3, the hash join buffer. And here clearly you can see that the optimizer was estimating 7 rows, but the actual number of rows were 10. So there's a mismatch over there in the estimation of the cardinality of this specific SQL ID. Here's another example where we have the SQL ID, the execution ID, and also there is a nested loop on row number 6. You can clearly see that we have an estimated rows of 12 by the optimizer, but the actual number of rows were 261. This is a clear indication that we should probably gather statistics on these specific SQLs. Last but not least, let's talk about fragmentation. And we know that as the data is changing inside our segments, right, we have deletes, inserts, updates. This can lead to a greater overall storage space usage, right? We can have fragmentation of tables and indexes. This could reduce the performance depending on the way we're accessing the data, right? So we can reorganize indexes using techniques such as rebuild. We can shrink, right? We can also reorganize tables using move or shrink operations. And we have the segment advisor that can help you to identify those segments that will have a benefit from that online segment shrink. This segment advisor is going to identify these segments and it's going to give you information about how much space is available to reclaim. It will perform this analysis by examining this usage and growth statistics, by also sampling the data in the segment, but also looking at the data in the AWR repository. This is configured to run automatically at regular intervals. You can modify this configuration as well. It will generate different types of advice. It will recommend online segment shrink. It will tell you if the object is a table or if it's not eligible for shrinking. And it's also going to record that the table has an excess of chained rows if that's the case, right? The way it looks like this is an output of the recommendation report from the segment advisor. We have a table here that the recommendation is to shrink. We can reclaim around 16 megabytes for this particular table. You can see that the total allocated space is 19 megabytes. That means that this table is only using 2.7 megabytes, right? This is a table type. Last but not least, we have object reorganization, and this is designed to enhance database availability, right? We have a reorg wizard that is going to evaluate the reorganization operations, and it's going to generate an impact report, right? These reorganizations can be performed immediately, or you can schedule that for a later time, perhaps during off-peak hours. It's going to reorganize individual schema objects or the entire schema if you instruct the reorg wizard to do that. Provides continuity of service because there is no impact on end users. And when the reorg is complete, it's going to switch to the new reorganized object automatically, and it's completely transparent to the application users. In summary, what we saw today is that we have defined, I explained the diagnostics pack, all the data that we're gathering inside AWR, how we make use of this data, right, to identify issues. So we find issues using the diagnostics pack. We also have the fix, which is the tuning pack. We went through the SQL Tuning Advisor and all the advisors that we have available in order to fix problems that were identified using the diagnostics pack. The last step is to use real application testing, which is an additional database pack in order to validate issues using SQL Performance Analyzer. But now let's jump into a quick demo where I show you how to identify a SQL statement that is performing using a suboptimal plan, and how we can identify it and then tune it using SQL Tuning Advisor. Okay, here I have a test database where I have some workload running. I'll click on Performance, then I'll click to Performance Hub and click Ash Analytics. Remember that we were discussing about active session history, right? The page is bringing up the top graph where is providing information about the current active sessions in the database. And also we can see different colors in the graph. You can see on the right side that the green part represents the CPU utilization. Then we have the user IO, and also we have wait activity for those sessions. I scroll down and I have performance information related to the average active sessions. This is filtered by wait class. I can filter them by different dimensions. I have wait class, wait event, instance, service module. On the SQL side, I have SQL ID, the top level SQL ID, SQL plan hash value. For PL SQL as well, I can filter by PL SQL or the top level PL SQL. Resource consumption, the wait class, this is the one that I have right now, wait event, object, or blocking session. If I keep scrolling down, then on the right side, I have information about the SQL statements running in that particular time frame, right? Which in this case is 5 minutes from 6:10 to 6:15. I also can see that this is ordered by the amount of resources that the SQL ID is consuming. So the top one is the one that is consuming more CPU. We have 1.2, which accounts for 75% of the CPU usage in the database. And on the right side, I have the sessions that belong to these particular SQL IDs that I have. So making use of AWR data that the database is collecting, I'm able to identify the top offenders, right? I have these 6KD, D9D, A7V SQL IDs, right? So I'm going to click on the first one. I highlight that row, and you can see that right away I have the option to create a SQL tuning set. We already discussed what a SQL tuning set is. And also I can invoke the SQL Tuning Advisor by clicking Tune SQL. I'm going to click on that. SQL Tuning Advisor page comes up, I have a couple of preset inputs, like the name of the task. It's creating a SQL tuning set for me that has one SQL statement, of course. I can expand the SQL statements. And also the scope. Remember that I explained during the presentation that by default we have 5 minutes per SQL statement. I'm just gonna leave the default. And then I can schedule this task. I can run that immediately, or also instruct SQL Tuning Advisor to run later, right? I'll click submit. I want to run that right now. And this task won't take more than 20-25 seconds to complete. It's just one small SQL statement. Okay, completed. So these are the recommendations: create a SQL profile or create an index. We also can compare the explain plans. I'm going to click on that. The difference between the cost of the original one compared with the cost of the new explain plan if we implement the SQL profile. Go back to recommendations, select this one, and I'm gonna click implement. Okay, I can force the SQL profile implementation with the force matching signature of the SQL. In this case, I have a bind variable, so I'm not going to select that. I'm going to click yes. I want to implement that SQL profile, and that SQL profile was successfully created. I can go back to the SQL statement stats. If I click on Plan Control, you can see that I have the new SQL profile. It was created manually. It's enabled, and the time that it was created. In statistics, I can see the historical statistics of that SQL statement. This is the original plan hash value. Click manual refresh. Okay, you can see now I have two plan hash values for that particular SQL. The original one, which is the 1995, and the new one that was created, that is the 1198. You can see that as soon as we created the SQL profile, now the new execution plan is up, and I have the new execution statistics for that particular SQL ID. Okay, so we covered during this small demo how to make use of AWR data that the database is collecting using the Diagnostics pack, and also using the SQL Tuning pack and the SQL Tuning Advisor, which is a tool inside the SQL Tuning pack, in order to fix that particular SQL statement. So team, this concludes my presentation, the webinar on the technical side. Let me know if you have any questions from our attendees.
All right, thank you, Alfredo. That was a great presentation, actually a great demonstration of moving from Diagnostics with Performance Hub into SQL tuning pack. So that was fantastic. Thank you. Very nicely done. So Peak Solutions wrote a report for us. It's really well researched. They did some extensive, deep interviews with many of our customers, put together a real quantifiable report showing cost reductions, cost avoidance, and the biggest thing probably was around the dramatic increase in DBA and IT staff productivity. So if you're looking to invest in doing some of these activities with Enterprise Manager, this is a great report to help justify some of that. So take a look at the link below. And we do have our webcast series. We have some upcoming events you can see on the calendar there, as well as many of our previous webcasts on demand. We are planning to post some workshops as well, so stay tuned for that as well, and those will be coming soon. The blogs are down on the bottom. We have some really good technical blogs, announcements, and other assessments that you'll see in our blogs. And join in the conversation. We have quite a presence on Twitter. We have a big community at /Oracle_EM. And then down on the bottom, we do have a very fleshed out YouTube channel. So take a look at some of the videos of demonstrations, of presentations, and so on our YouTube channel. All right, thank you very much, all of you, for attendance. Thank you for your questions and participation. Really appreciate that. Alfredo, great job on the presentation and demos. And thank you to our Q&A staff. Really appreciate that as well. So we'll see you again on the Deep Dive Enterprise Manager webcast series, and thank you very much.